Multiplication is repeated addition. Simple multiplication can be accomplished once you have memorized multiplication facts. The size of multiplication problems that you can solve will be determined to a certain extent by how many multiplication facts you have been able to memorize. At one time, there was a common belief that a person must memorize the entire multiplication table in order to function effectively in day-to-day activities. The availability of low-cost electronic calculators has changed that perception. It is still critical that you learn the rules and guidelines that determine the operation of multiplication. But having to memorize the multiplication table no longer prevents one from using multiplication. Whenever you see this sign, the times sign, you know that you must perform the operation of multiplication. 3 times 5 means to add 3 together 5 times. It can be written as 3 plus 3 plus 3 plus 3 plus 3 equals 15. 5 times 3 means to add 5 together 3 times. This can be written as 5 plus 5 plus 5 equals 15. They both result in the same sum, 15. Therefore, 3 times 5 equals 5 times 3. Changing the order of the numbers will not change the value of their products. Multiplying by a single-digit number is initially set up by writing the multiplier under the multiplicand. For example, in 23 times 5, the multiplier 5 is written below the multiplicand 23. The ones place of the multiplier is positioned under the ones place of the multiplicand. Once the problem has been set up, the first step is to multiply the multiplicand number in the ones place, 3 times 5, which equals 15. 15 is called a partial product. The second step is to multiply the multiplicand number in the tens place, 20 times 5, which equals 100. 100 is the other partial product. The third step is to add the partial products together. 15 plus 100 equals 115. Using a two-digit multiplier follows the same rules. For example, in 23 times 25, the multiplier 25 is written below the multiplicand 23 and the place values are aligned. The product for 5 times 23 is computed in the same way you have already learned. In this example, 115 is a partial product. Write 115 under the multiplier and multiplicand, making sure that the ones place of the partial product is aligned under the ones place of the multiplier and multiplicand. Next, determine the partial product of 23 times 20. In this example, 460 is the second partial product. Write 460 under the first partial product, making sure that the place values are aligned. In the final step, add 115 plus 460, the two partial products, to obtain the sum of 575. Thus, 575 is the product of 23 times 25. Using three-figure numbers involves a continuation of the rules you have just learned. For example, in 123 times 25, the multiplier 25 is written below the multiplicand 123. The ones place of the multiplier is positioned under the ones place of the multiplicand. Begin by multiplying 123 times 5. The first partial product for 123 times 5 is computed to be 3 times 5, which equals 15, plus 20 times 5, which equals 100, plus 100 times 5, which equals 500. Thus, 15 plus 100 plus 500 equals 615 for the first partial product. Obtain the next partial product by multiplying 123 times 20. 3 times 20, which equals 60, plus 20 times 20, which equals 400, plus 100 times 20, which equals 2,000. Thus, 60 plus 400 plus 2,000 equals 2,460 for the second partial product. In the final step, add 615 plus 2,460, the two partial products, to obtain the sum of 3,075, which is the product of 123 times 25. Another method of multiplication is to carry over digits. For example, 54 times 6 is set up in the usual way with the multiplicand 54 written over the multiplier 6 and the place values aligned. Multiply 6 times 4 ones, which equals 24. Place the 4 under the multiplier 6 and write the 2 over the 5 in the multiplicand. Next, multiply 6 times 5 tens, or 50. 6 times 5 tens equals 300. 300 plus the 20 carried over equals 320. Since you already have 4 in the ones place, you would write 2 in the tens place and 3 in the hundreds place. Thus, the product of 54 times 6 is 324. Multiplying by numbers ending in 0 is easy when you remember a few simple rules. To multiply a number by 10, place one 0 to the right of the number. For example, 35 times 10 equals 350. To multiply a number by 100, place two zeros to the right of the number. For example, 49 times 100 equals 4,900. To multiply a number by 1,000, place three zeros to the right of the number. For example, 58 times 1,000 equals 58,000. Multiplying with 0 in the multiplicand is done in the same way as any other multiplication operation. For example, 607 times 4 would be written by putting the multiplicand 607 over the multiplier 4. 7 times 4 is 28. Write 8 in the ones column and place the 2 over the 0 in the multiplicand. 0 times 4 is 0, but you can carry the 2 into the tens column. 600 times 4 is 2,400, so you place 4 in the hundreds column and 2 in the thousands column. The resulting product is 2,428. To multiply by numbers ending in 0, multiply the numbers without consideration for the 0. For example, 34 times 20 would be treated as 34 times 2, which equals 68. Then, add the 0 to the end of the partial product, which equals 680 for the final product. The same rule would be used for multiple zeros. For example, 25 times 300 would be treated as 25 times 3, which equals 75 as a partial product. Then, two zeros would be added to the partial product for the final product of 7,500. The most common method for checking a multiplication problem for accuracy is to use the interchange method. This method is done by interchanging the multiplicand and the multiplier and then multiplying again. For example, 12 times 35 equals 420. 35 times 12 is also equal to 420, so the operation is correct.